Good morning, students. Let us continue with the yesterday part. I am audible now? Please give anyone confirmation. Okay, fine. Thank you. So, good morning once again. We will continue with the gamma function. So, last lecture I started with the definition of gamma function, properties of gamma function, and second definition of gamma function. It is an improper integral, and how that improper integral can be solved, that we have seen in the last lecture. So first few minutes I will revise it, only the properties or the including definition also. So for the revision, anyone can tell what is the definition of gamma function? First point, how the gamma n can be written as in terms of improper integral. That is the first definition. Yes, immediately. Very good. Integral 0 to infinity e raised to minus x raised to n minus 1, and we have seen that when the improper integral you are converting to the gamma form, our main focus is to obtain the kernel, that is nothing but e to the power minus x, and the same integral we may write in the form, because definite integrals are independent of the parameter. The same integral I will write e 0 to infinity e raised to minus y into y raised to n minus y, because we know the property of definite integral. Again and again I am telling, definite integral is independent of the parameter. Whether you are using x, whether you are using y, whether you are using t, all integral will evaluate the same thing. Or the same integral we may write as integral, same integral we may write as integral 0 to infinity e raised to minus t into t raised to n minus 1 dt. So everywhere when you are reducing that improper integral to the gamma form, our focus is to obtain the kernel, means what? E to the power minus parameter term that I have to obtain. Okay, so this is the definition. Now can anyone recall the properties? We have seen four properties of gamma function. Now the first property, what is the evaluation of gamma 1? Yes, what is the evaluation of gamma 1? Unmute and tell. Okay, I will take the name then. I will take the name. Kawade. Kawade, are you there? What is value of gamma 1? Don't know, right now? Yes, gamma 1 is 1. So the next property was seen, gamma of n plus 1 for any real number which is a positive. Yes, Rutuja Patil. Sorry, Ruturaj Patil. What is a gamma n plus 1 if n is greater than 1? In terms of, which is also called as a reduction formula for gamma function. That is gamma n plus 1 is written in terms of gamma n again. Quickly. Yes, very good. It is n into gamma n. And the same property we have reduced or we have deducted if n is an integer. What is gamma n plus 1, Prerna? If n is integer. N into gamma n already we have written. If n is integer, after that we have seen integer in terms of factorial, n factorial. Okay, so fourth one, Ayushi, what is gamma of 1 by 2? Roll number 55, I think. Ayushi, are you in the meeting? Yes, what is gamma 1 half? No, 1 half I am asking, and at that time I told that to obtain the result of gamma 1 half we require definition of beta function without root pi, not gamma. So make a differentiate between gamma and root. So for gamma, how we are writing? One vertical, one horizontal. This is a gamma. Root is like this. Okay, while writing in the examination also, this is your gamma and this is your root. or square root we can write, say. Okay. Now let us continue with the example. Again, the focus should be, when you are reducing a particular integral by gamma, our focus should be obtain limits of the integral 0 to infinity and kernel, and that kernel is nothing but e to the power infinity. I think three examples we have seen yesterday. Now the fourth example, evaluate the integral 0 to infinity, x raised to m into e to the power minus ax raised to n dx. Now in the first step, I will write that first integral as a I. Okay. So help me to guess the substitution. So let I is equal to integral 0 to infinity x raised to m into e to the power minus ax raised to n dx. Yes, anyone guess what will be the substitution here? Now focus should be kernel. Now this is exponential term. Accordingly, you have to select. What is your substitution? Yes, anyone can guess? Very good. We require e to the power some parameter. That's why whatever this term is there. So for that, I will use the substitution. You may use t, you may use y, whatever that. So that's why in this case, my substitution is ax raised to n is equal to t, or x raised to n is equal to t by a, or the first expression you are writing t in terms of x, last expression I am writing x in terms of a, t and a. So taking nth root on both sides, so we can write t raised to 1 by a, and I think a raised to, 1 by n I have to write. So here I have to write 1 by n. Now, so by using this, you are changing the variable x to t. So differentiate this by taking differentiation of both sides. Right side 1 upon a raised to 1 upon n is constant, that I will write as it is. So derivative of t raised to n by using x raised to n formula, what should I write? 1 by n t raised to 1 by n minus 1 into dt. Okay, into dt. So actually your substitutions are, first one, either you can refer this one or this one. Okay, one you are writing x in terms of a, other you are writing t in terms of a. Now the given integral, for the given integral, see the limits, the given integral for x, and the limits are given from 0 to infinity. So that I will write. So for limit, given limits are 0 to infinity, now to obtain t, the value of t, that highlighted yellow color I am using, you can use. Substitute x is equal to 0. What is a t? Yes, anyone? If you substitute x is equal to 0 in this relation, this is your substitution. Okay, x is equal to 0. What is t? Quickly. 0. If x is equal to infinity, what happened? Again infinity raised to n, it becomes infinity. Okay, so the new limits again you are getting from 0 to infinity. New limits also you are getting 0 to infinity. That's why this integral I will write new limits again 0 to infinity. First I will write this exponential term. So that is nothing but e raised to minus t, because your substitution is ax raised to n is equal to t into x is given by, first I will write the value of x, that is t raised to 1 by n divided by a raised to 1 by n, that whole raised to m. So this is your x raised to m. Now the next you have to replace the value of dx as this one, the value of dx is given by 1 upon n into a raised to 1 upon n into t raised to 1 upon n minus 1 dt. So in the next step, what I will do, constant term I will take outside. So I will highlight the constant term, this one and this one. What will be the resultant? That you have to write in the denominator. First I will write 1 upon a to the power. Yes, Aditya, what will be the power of a? Aditya Koplani, right now? I have highlighted both terms by yellow color. Oh, no. Just look at the term. So here we are having m by n, okay? And here we are having n by n. So addition of the power, what will be the resultant? Oh, no. You are not getting. I am collecting the terms of a together, and at the same time I am writing that integral that term outside the integral. Base is same. Addition of the power. The first power is what? This one. First power is what? Here I am highlighting. What is first power? 1 plus n. You have to take this together, na? Yes. First term is m by n, second term is 1 by n. So all together this is m plus 1 divided by n. So also I will take this 1 upon n also outside, okay? That multiplied by n outside into integral 0 to infinity e raised to minus t as it is, collecting the terms of t together. Now here you are having one term, here you are having second term. Yes, power you have to tell. First is m by n plus 1 by n minus 1 dt. Now whether can I consider the second integral as a definition of gamma? Because for the definition what I required, gamma n, if required, gamma n is nothing but integral 0 to infinity e raised to minus t raised to something minus 1 dt, and this is nothing but something whatever you are writing. Yes, Tanmay. Outside constant term I will write as it is 1 upon n into a to the power m plus 1, that whole divided by n. So what I should write? You can compare term by term. E raised to minus t, e raised to minus t. Limits 0 to infinity, limits 0 to infinity. T is there, t is there. Something means what? That term only I will write. This one and this one. Something minus 1 you have to write. And the answer is nothing but gamma of that function. What is that term? Yes, that together you can write as m plus 1 divided by n. So further, if the particular values are given, further you can simplify that answer. Otherwise, so here I will consider thus evaluation of the integral is 1 upon n into a to the power m plus 1 divided by n into gamma of m plus 1 divided by n. So that is your required answer. Okay. So these are the general form, and after that I am taking particular examples. Suppose the next example is fourth example or fifth example. Continue with that. Evaluate the integral. Evaluate. Now I will take the name of the student. They have to unmute and tell the answer. Integral 0 to infinity root x into e to the power minus x square dx. So little bit I will scroll the screen. Okay, this much is sufficient. The first step, I will call the given integral as I. I will call the given integral as I. So let I is equal to integral 0 to infinity root x into e to the power minus x square dx. What is your substitution? Okay, Tanmay. Tanmaya. Okay, what is your substitution? Yes, very good. Yes, very good. Put x square is equal to t. If x square is equal to 2t, then what is x? T raised to 1 by 2. So what I did here, both side I am taking square root. Now differentiate this. Dx is equal to 1 by 2 into t raised to 1 half minus 1. What it will come? Minus 1 half dt. Now again, so to find the limit, either you can use this substitution or this substitution as per your convenient. So as or the given limits when x is equal to 0 Now what is your t? You can use this substitution. X is equal to 0, t is also 0, right now. X is equal to infinity, what is t? Infinity square again. That means again the new limits you are getting 0 to infinity. So the same integral I will write new limits from 0 to infinity. First I will write exponential term, this one, that is the kernel. Focus is to obtain the kernel, that is e to the power minus x square, and x square is t, and value of x is t raised to 1 by 2. Okay, the value of x is t raised to 1 by 2. This term I am writing, this term. So further, how that root x can be adjusted? Further raised to 1 by 2 na. So here root x is nothing but x raised to 1 by 2. So further raised to 1 half, dx is given by 1 upon 2 into t raised to minus 1 half dt. Now from this I will take constant term. Rida, be ready. What will be the power of t? You have to tell. Rida, roll number 19 something. Okay. So from this minus 1 by 2 I am taking outside, integral 0 to infinity. Now this term is e raised to minus t. What is t to the power? You have to collect the terms of t together. This term, this term. Here if required I will write calculations. Rida, are you in the meeting? Okay, tell me. Don't tell directly, I don't know, sir. I will help you. Okay, what is the power of first t term? I will circle it. Now this is your first t term. What is the power of t? Bolo. Okay, it is 1 by 4. Your friend is helping you. Okay, second one is t raised to, at least tell me second power. Yes, if base is same, use the law of indices. What is the addition of these two? 1 by 4 minus 1 by 2. Minus 1 by 4. Means here you are multiplying by 2, here you are multiplying 2. That is minus 1 by 4. So I will write here. So this is minus 1 by 4. Just a minute, I have to change the color. It is minus, why it is not working? Just a minute. This is minus of 1 by 4 dt. Now the next question is open to all. This 1 half I will write outside. Now you can see for the integral, limits are from 0 to infinity. Limits are from 0 to infinity, and that kernel also you are having. That kernel also you are having. Okay, limits you are having from 0 to infinity, and also we are having that kernel e to the power minus t into t raised to minus 1 by 4. So can I consider this as a gamma function? If yes, what will be the gamma of? Yes, what is the gamma of? How to adjust the term? So for definition of gamma function, you look at here. So gamma n can be written as integral 0 to infinity e raised to minus x into x raised to n minus 1 dx. This power you have to write something minus 1, something minus 1, this one. So that means to write that number as a something minus 1, you have to make adjustment plus 1 minus 1, and it defines gamma of this number. And what is it? What is it? 3 by 4? It is gamma of 3 by 4. It is gamma of 3 by 4. So further if you want to simplify, so 3 by 4 minus 1, it coming as a negative. That's why we can't apply any property. So that's why consider the final answer as thus Thus, the final answer I is equal to 1 upon 2 into gamma of 3 by 4. That is your final answer. So one more example I will write. Try to evaluate that. So the sixth example. Any doubt? Any questions? Sixth example. Evaluate integral 0 to infinity. Okay, I will directly continue the next type. Suppose sixth example. Evaluate integral from 0 to 1 x raised to m minus 1 into log x raised to n minus 1 dx. Okay, this is the next type. This is third type of example. So for this example, first I will call the given integral as I. So let I is equal to integral from 0 to 1 x raised to m minus 1 into log x raised to n minus 1 dx. Remember, when you are having an integral of the type limits from 0 to 1, limits from 0 to 1 and limits from 0 to 1 and integrand involving logarithm, always use the substitution as a standard result. Put x is equal to directly kernel of the integral, and what is that term? E raised to minus t. So directly put x is equal to e to the power minus t. Remember, once again I repeat, when you are having a limits of the integral from 0 to 1 and integrand involving logarithm, always use the substitution x is equal to e raised to minus t. Now I will differentiate this. If you differentiate this, dx becomes integration of e raised to minus t is minus of e to the power minus t dt. Okay. Now come to the limits. Given that when x is equal to 0 and when t is equal to 1. So tell me, when x is equal to 0, what is the value of t? I will wait for your response. When x is equal to 1, what is the value of t? So for your understanding, I will do the rough calculations. What happened? 0 is equal to e to the power minus t. Then what is t? Yesterday we have seen that standard result. E to the power something is equal to 0. What is the value? Omkar, what is the value of t? What is the value of t? Infinity. Yesterday we have seen that, na? It is infinity. It is e to the power in minus infinity is equal to 0. That we have seen. Now the second one is equal to 1 e to the power minus t. Then what is t? Anything raised to is 1. Yes? Yeah. So the new limits of the integral is from infinity to 0. So after that, if any logarithm term is there, that also calculate separately. So consider log of x, means that term I am converting in terms of t. So which can be written as log of e to the power minus t. And we know that logarithm and exponentials are inverses of each other. It comes as a minus t. Okay. Therefore, the given integral can be converted to integral new limits of the integral from minus infinity to 0. Sorry, minus, not minus, it is infinity to 0. X is nothing but e to the power minus t and it's raised to m minus 1. Okay, x raised to m minus 1. Log x is minus t, it's raised to n minus 1. And dx is given by minus e to the power minus dt. Remember, always this negative sign I will use to change the limits of the integral. So if I use this negative sign to change the limits of the integral, what will be the limit then? 0 to infinity. Okay, this negative sign absorbing. So after that, e to the power, yes, minus tm minus t, verify whether I am writing correct or not, minus tm minus t into minus 1 raised to n minus 1 into t raised to n minus 1. So this negative sign I have used to change the limits of the integral. So remaining is e to the power minus t dt. So further verify the calculation part again. What happened? Something is wrong. Just I will check. E to the power minus t raised to m minus 1. Okay. So in the statement what happens? I have taken raised to. I will correct it. Suppose raised to m and raised to n is only. Okay, I will correct it. This is log x raised to n. Then what happened? This one is x raised to m. This one is x raised to n only. I will correct it. So this, by this way also you can proceed. I will continue with my notes, whatever I have written in my notes. Then after that, this step I will cancel. After that, procedure is same. So the first term is e raised to minus tm into minus 1 raised to n into t raised to n. This negative sign is absorbed, minus t dt. So after that, I will collect the term minus 1 raised to n is a constant, that I will write outside. So integral 0 to infinity e to the power minus t I will take common. Then the remaining term is m plus 1 I think into t raised to n dt. So can anyone help me? What should I do next? Whether it is converted to the gamma, because for gamma function I required e to the power minus t as the kernel. But here I am having, once again I write properly that term. This one is m plus 1 into t. So whether it converted to the gamma, if not, what I should do? Tell me. So what should I do? What is the kernel? What is the kernel I required? Yes, Siddhi. Again you have to use the substitution, na? You have to use put m plus 1 into t is equal to y, because in the gamma function, gamma n is given by integral 0 to infinity e raised to minus y into y raised to n minus 1 dy. So my focus is to obtain this term, Okay, that's why this is my substitution. Or the same thing you can write, t is equal to y divided by m plus 1. Is it right? Can you proceed? This one I will rub. Okay. Now something I written wrong, or it's correct? Y is m plus 1. Okay, dt. So from this, so if you differentiate both side, this dt is given by 1 upon m plus 1 is a constant into dy. Now given limits for t, they are given as a 0 and infinity. Now the new limits for y also comes as a 0 to infinity, because if you substitute t is equal to 0, then y is also 0. If t is equal to infinity, y is also infinity. So 2 times substitution you are using. So that's why further I will proceed. Now this integral can be written as new limits 0 to infinity minus 1 raised to n, that you have to write as it is, minus 1 raised to n. New limits 0 to infinity, it is e to the power minus y. T is given by y upon m plus 1 raised to n, and dt is given by dy upon m plus 1. So further it can be written as minus 1 raised to n, and further I will take m plus 1 raised to n plus 1, that term outside. So 0 to infinity e raised to minus y, y raised to n dy. So what this integral defines? What this integral defines? Yes, anyone? The remaining term I will write as it is. That is minus 1 raised to n into 1 upon m plus 1 raised to n plus 1. It is gamma of. Is it right? Shivani Patil? So what should I do here? I have to make the adjustment, and this comes as a gamma of n plus 1. It comes as gamma of n plus 1. And this one is the final answer. That you have to consider the final answer. So if the integrand involving logarithm function, so how to evaluate the integral? So proceed with the next. Seventh example. Evaluate integral 0 to 1 square root of log of 1 by x, square root of log of 1 by x dx. Okay, so the first step, I will call this integral as I. First step, I will call this integral as I. So let I is equal to integral 0 to 1 square root of log of 1 by x dx. Now further the same thing can be written as integral 0 to 1 log of 1 by x, that whole raised to 1 by 2. Square root is nothing but 1 by 2. Now just I told, what is the substitution? What is the substitution? This substitution part I will write to the right side. What is the substitution? Yes. Yes, Shruti. What is the substitution? What is the substitution? Okay. What I told in the sixth example, when the limits of the integral from 0 to 1 and the integrand involving logarithm, then always use the substitution. Okay, I tick mark it. Once again I repeat, when the integral having limits 0 to 1 and integrand involving logarithm function, don't make a confusion whether I have to put log x is equal to t or log of 1 by x equal to t or minus t, whatever that. Remember, this is a standard form. Limits 0 to 1, integrand involving logarithm, always put x equal to e to the power minus t. Yes, Shruti, what is the substitution? Okay, this is a common. Remember, if you refer the books, they have given according to log x or log 1 by x. So if x is equal to e to the power minus t, then dx is given by that common part you have to write everywhere, e to the power minus t dt. Limits also I have explained. Limits, x limits given as a 0 to 1, then t limits you will get infinity to 0. That part I explained, that's why directly I am writing. But in this case you have to calculate log of 1 by x. So consider log of 1 by x, so which can be written as log 1 minus log x, that is log 1 is 0 minus log of e to the power minus t. And we know that logarithm and exponentials are inverses of each other. It comes as minus of minus t and it comes as a t only. So log of 1 by x comes as a t only. So that's why this integral further I will write new limits from infinity to 0. So this bracket, whole bracket is simplified as a t only. So that's why I will write t raised to 1 by 2 and dx, just we are simplified dx can be written as minus into e to the power minus t dt. Now for this negative sign, I will change the limits. For this negative sign, I will change the limits. So this integral I will write as 0 to infinity because of this negative sign. And suppose first I am writing exponential term into t raised to 1 half dt. So can I consider this as a definition of gamma function? Yes or no? Can I consider this as a gamma function? Limits 0 to infinity kernel e raised to minus t. Can I consider this as a gamma function? Vaibhavi? If yes, then tell me the gamma. Is gamma of? Yes, you have to make adjustment. So this is a gamma of 1 by 2 plus 1 is nothing but gamma of 3 by 2. Now further it can be simplified by using the property that gamma of n plus 1 is written as n gamma n. Means you have to reduce that number by 1 in each step. So what it will become? It come as a 1 half gamma 1 half. And further if you reduce that gamma 1 half by 1, it comes as a negative. That's why you have to stop. So the final answer is 1 half, and by the fourth property gamma 1 half is root pi. So that is the evaluation. That is the final evaluation of the integral is 1 half into root pi. Okay. So the next one more example on logarithm, and then I will shift to the next one. Today I have to complete this. So eighth example, evaluate integral 0 to 1 dx divided by in bracket x into log of 1 by x raised to 1 half. Okay, now call this integral as I. And use the common part. So let I is equal to integral from 0 to 1 dx divided by, this is x into log of 1 by x raised to 1 half. So further it can be written as 0 to 1 x raised to minus 1 half into log of 1 by x raised to minus 1 half dx. Okay, again Kavita, can you tell what will be the substitution? Anyone can correct? Listen now what I am telling. Now see, for the first one, limits from 0 to 1, integrand involving logarithm. So for that I told put always x is equal to e to the power minus t. That is a standard substitution. Okay, so that's why the part is common again. Dx is given by minus of e to the power minus t dt. Same thing you have to write. Limits, given limits for x from 0 to 1. For t it comes as a infinity to 0. Now again we are having log of 1 by x. In last example we did it. So log of 1 by x can be written as log 1 minus log x. It can be written as log 1 is 0 minus log of e to the power minus t. Okay, I will write t directly because in last example we did that. Therefore, that integral can be reduced to the new limits from infinity to 0. Okay, x is e raised to minus t and raised to minus 1 half once again. So log of 1 by x is t. Log of 1 by x is t. Okay, log of 1 by x is t, and dx is minus e to the power minus t dt. Again I am highlighting this negative sign I will absorb to change the limit of the integral. Okay, and collecting the similar terms together. So it can be written as limits from 0 to infinity, exponential term together I will take, and I think it is only t na, something I missed to write, raised to minus 1 half I have to write. Yes, it is raised to minus 1 half dt. Can anyone help me to write the power of e? First one is t by 2. Second one is minus t. Is it right? Is it right? At least tell yes or no. Yes, is it right or wrong? Okay. So it can be written as minus t by 2. Now next. Now how to evaluate the remaining part? Yes, anyone? It is not in the standard form still. Because for the standard form we require limits from 0 to infinity and e to the power minus parameter, that is the kernel, but we don't have. Then what to do? What to do? What to do? Very good. So once again, for the parameter we require e to the power minus y. That's why put, once again you have to make substitution. Put t by 2 is equal to some y, or t is equal to 2y. So this implies dt is given by 2 times dy. Now limits. For the limits, t limits given as a 0 to infinity, y limits. So you can use this substitution. So to obtain y, you can use this one. Now when t is equal to 0, what about y? Obviously, it is also 0. When t is equal to infinity, obviously it is infinity. Therefore, so this integral can be reduced to the form. For the new integral, limits are from 0 to infinity, e to the power minus y. This is infinity. So t is given by 2y and raised to minus 1 half. Dt is given by 2 times dy. Now from this 2 term I will take common. What is the power? Now here you are having 2 raised to minus 1 half, that I will write first. T raised to minus 1 half, and here you are having plus 1. And the remaining is e raised to minus y into y raised to minus 1 half dy. So the outside is t raised to minus 1 half and plus 1. So it is 0 to infinity e raised to minus y. So this I will write plus 1 minus 1. Okay, for gamma part, and this become y raised to 1 half minus 1 dy, and it is gamma of, what is it? 2 raised to 1 half, what is it? Gamma of 1 by 2. And we know this is nothing but root 2. Gamma of 1 half is nothing but root pi. So thus evaluation of the integral is square root of 2 pi. That is your final answer, square root of 2 pi. Okay, so one example, if further examples on logarithm, that I will write or I will give for homework. Okay, next I will continue the remaining 2 types. Still we are having 10 minutes, and this is the end for the gamma. Ninth example. These are the standard form. I am not taking example form wise. Evaluate integral 0 to infinity x raised to a divided by a raised to x dx. So this is another form. When I am taking the general form, so you have to remember this is a particular type or separate type for the gamma. Let I is equal to integral 0 to infinity x raised to a divided by a raised to x dx. Remember, so in such case, what is the substitution? So directly put the denominator term. This term is in the denominator na, a raised to x. A raised to x is equal to e to the power t. Why I am taking a power positive? Because when you take that term in the numerator, that becomes e raised to minus t, and that is the kernel of the beta form. And from this I have to obtain x. Anyone can tell? This is a way to identify the substitution. Huh? This is the way to identify the substitution. So from this, suppose I have to obtain x. Yes, anyone? At least tell me method. How to find x in terms of t. Okay, that is the value of t in terms of x and value of x in terms of t. Because we have to use substitution for x. Okay, for that you have to do logarithm, that intermediate values I will take. Both side you have to take log on both side. That will come as a x log a is equal to t log e. But we know that log e is 1. So x is equal to t divided by log a. T divided by log a. And this is your actual substitution. This is your actual substitution. So if this is the substitution, differentiate both sides. This implies dx is equal to dt divided by log a. Dt divided by log a. Now for the limits are given 0 to infinity. So for x, limits given as a 0 to infinity. So what about t? Can you guess? If x is equal to 0, then what is t? You can solve this equation. If x is equal to 0, then anything raised to 0 is 1 e into t. बरोबर है? So taking log on both sides, log 1 is 0, t into log e. So log e is 1, 0 is equal to t. Means what happen? This also you are getting 0. In the same manner, you can simplify and you will get upper limit also as a infinity. That limits remain same. Limit remains same. Therefore, so this integral becomes new limits 0 to infinity, and this e raised to minus x, sorry, e raised to x I will write first, and that you are substituting as e raised to t, and that you have to write in the numerator. So that's why it becomes e to the power minus t. Now replace the value of x as t divided by log a. T divided by log a raised to a. dx is dt divided by log a. Dt divided by log a. So from this 1 upon log a constant term I will take outside the integral. And what is the power then? What is the power? Log a raised to 1, and here log a raised to 1. So its power becomes a plus 1. And remaining is e to the power minus t to the power a dt. And remaining integral is in the gamma form. So it can be written as plus 1 minus 1. And it defines gamma of a plus 1. Therefore, for the final answer, it is gamma of a plus 1 divided by log a raised to a plus 1. So this is a final answer. Okay. So one particular example on this case. Still I have to cover two methods. So 10th example, suppose. 10th example. Evaluate integral 0 to infinity x raised to 7 divided by 7 raised to x dx. Means what I did here, particularly I am giving the value of a as a 7. Value of a as a 7. Therefore, for this solution, I will call this integral as a I. So let I is equal to integral 0 to infinity x raised to 7 divided by 7 raised to x dx. Shreyash Patil, what is the substitution? Suraj Suryavanshi, what is the substitution? Manjit Patil, what is the substitution? Okay, continue. So substitution is 7 raised to x is equal to e raised to minus t. So that's why taking log on both sides, you will get x is equal to t divided by log 7. You will get t divided by log 7. So this implies dx is equal to dt divided by log 7. So just I was explaining in the last lecture, similar to that, your substitution is x equal to 0, then t is also 0, x is equal to infinity, then t is also infinity. Therefore, this integral becomes 0 to infinity e raised to minus t, t divided by log 7, raised to 7, and dx is given by dt divided by log 7. So log 7 term I will take outside. It becomes 1 upon log 7 raised to 7 plus 1 integral 0 to infinity e raised to minus t, t raised to 7 dt. So it can be written as plus 1 minus 1. So the answer is gamma of 8 divided by log of 7 raised to 8. And gamma of 8, we know what is the value. It is a 7 factorial divided by log of 7 raised to 8. Yes, anyone can tell me what is a 7 factorial?